Now let's take a look at how to handle multiple sentences and entire end-to-end pipeline we have unpacked until now. We'll just pack it back again and finish our whole using transformer section. Okay. So we know this first tokenizer, second model, third output processing. So words and sentences are given as input. Tokenizer takes them, converts them into numerical IDs, which is based on mapping a unique word to a unique number. Model takes in number as input, a PyTorch tensor, and then process it further, adds meaning to it, and then refines it further and further, and then it does decision with head of the model. We have body of the model, which is doing the learning part, and head of the model, which is doing the decision part, and then we have the output processing. Okay, so let's see that. The first thing, everything in transformers starts from transformers library. There we specify the model name, and to get the pre-trained model as is, we use from pre-trained function. Okay, there is an error if we do brackets like this. So bird tokenizer, it's not initialized as a class, and there is a method on top of this. So we have seen in the previous one, tokenize maps word to tokens, then convert tokens to IDs, maps each word to a unique numeric ID. This is what we call here. And by saying decoding, we convert the numerical IDs back to the words. So final output needs to be converted back into the format we understand. So decode comes into picture. We can do all this, or we can just do tokenize, not this tokenize, but tokenizer, direct call tokenizer. So here the thing is, if the sentences which are passed to the tokenizer, they are of different length, what happens? This is a very small behavior, but it has very important consequences because matrix needs to be of the same length. We can't have a pyramid being multiplied with a matrix. No, unfortunately, we need all the height and width of the matrix same. That's why padding option comes into picture. So when I say hello world and bye bye world, here just one extra word. What impact does it have on the tokens, numeric IDs built from the words? You see, 101 generally is mapped as a start of the word, and 102 is end of the sentence, start of the sentence, end of the sentence. So we have hello is 19082 and world is 1362. Bye is 11901. This bye is 11901. World is this. So two elements versus three elements. But when I say padding equal to true, what happens? We have 19082, 1362, and then 102, and then we have 0. And here, this output is same. So because of this extra 0, it is like one extra word is added to make all of them same. Or I can do one interesting thing. I could do this. Say 1, 2, 3, 4. And let's execute all of this. So now, because I've added 4 words here, this first sentence should have 2 extra words added. And does it have 2 extra words added? 0 and 0. Yes, it does. So tokenizer, we start with padding equal to true. It returns the numbers. Now, if you want to pass it to model directly, we need to convert it to PyTorch tensor. So after we have converted something to numbers, we want a library which is optimized for linear algebra on those numbers, and that's PyTorch. So here, return tensors equal to PT is the format. This is not very Pythonic. Any code which is not easy to read code is bad code. This PT should have been preferably PyTorch or at least Torch. But for some reason, it is just PT. We have to remember this returns tensor, everything to the model is in format of tensor because it's a PyTorch library. The model is written in PyTorch library and it is the format. So that's it. So tokenizer, when we have multiple sentences, we directly call, pass them to the tokenizer we instantiate, and we say padding equal to true, and we say return tensor equal to PT. So entire end-to-end pipeline, which we saw here, 1, 2, 3, this entire pipeline in code is again here. This import transformers, and if we just do it like this, checkpoint specifies the model to be downloaded, then transformers dot I special. What is the pipeline? 1, 2, 3. Tokenizer, model, and then processing of the output. So tokenizer, either I give auto tokenizer or the model I have chosen. So I can choose BERT model, I can choose GPT model, I can choose GPT-3 model, I can choose something else, or auto tokenizer and specify the checkpoint itself, and it will figure out the model and everything is fine. So auto tokenizer I chose, auto model I chose. For this model, the head is sequence classification. The head is sequence classification. You will understand it when you watch models lecture. So the concept here is model is made up of body and head. Head is where decision making happens. Body is what extracts the information, extracts the patterns from which decision needs to be taken. So they are separate. So sequence classification head. So we can, change it and apply a different head. That's why we talk like this. So tokenizer, we say padding equal to true. We say return tensors equal to PT, and truncation, I have just said true, and it doesn't matter. And we output, and voila, answer is there. So end-to-end pipeline, but going into details of models, tokenizer, why we need to use padding, and we know how to use transformers now, end to end. Then next comes the remaining lectures.